This is my project for my distributed systems class that I did along with 3 other classmates called PennCloud. Essentially, what PennCloud is a distributed cloud environment that supports multiple different features like a drive service and a mail service. So when you access PennCloud, you get this login screen where you can either sign in to an existing account or create a new account. So in this case, I have a pre-configured account called Bob that I'll sign into. So then you're taken to the main page where it tells you about what services we offer. So the main 2 services are a drive that allows you to manage files and folders, and a mail service that allows you to email other users within the service. So first I'll demonstrate the drive functionality. So if I go into the drive, and you can see there's a couple different pre-configured folders and documents here that are uploaded to the drive already. But for example, if I wanted to go into school and upload a folder or create a new folder called distributed, I can create that folder, and that folder is within this school folder. Now, if I go into distributed and say I want to upload a lecture to distributed systems, and I choose lecture 19, I upload lecture 19 here, and now lecture 19 PowerPoint is here within the distributed folder. Now say I wanted to move distributed from within the school and move it out to root. So I can just click this move button and move distributed to root. Now it's not within school, it's within root, it's distributed folder. And if I go inside of it, then you can see that lecture 19 is still within this distributed folder. To demonstrate that this PowerPoint is not corrupted, I can now download this folder or this file. And this file is downloaded here. A copy is made, as you can see by that 1. And if I open up this file, you see that the PowerPoint is not corrupted. And this drive persistency works. There's a couple other features to this drive. We have this rename functionality where you can rename folders. So in this case, it got renamed to distributed 1. You can also delete folders or files. So if I delete this distributed 1 folder and fresh, you can see that this folder doesn't exist anymore, in addition to the documents inside that folder. So it's a recursive delete. The other main functionality in this project is the mail functionality. So in this case, it allows you to email other users. So if I want to compose a new mail, send it to, for example, Charlie and Cloud, and title it testing, and then say, hi, this is Bob, and send the email. And if I go to a different tab, incognito tab, logged in as Charlie, and refresh, you can see that this testing email is there with this new timestamp that I just sent. You can also do some other functions that we support, like reply to the email, forward it to a different user, delete the email, etc. So if I reply to the email and say, hey, this is Charlie. We also support attaching files to emails. So say I want to attach a file portfolio. And send that to Bob. If I go back to Bob, now my Bob tab, I can see this email that I got from Charlie. And this is the content of the email, and then the original email is here. Also, the attachment is here too. So in addition to deleting emails and all the normal stuff regarding emails, you can also send emails to Penn-hosted domains. So like if the Gmail account is a Penn Gmail account, then we support emailing those external users as well. We also have other logistical things like changing your password. Now I can get more into the inner workings of the system. So if I go to the admin console, you can see like all the different nodes that we have to support the system. So in the front end, which is supporting the drive email functionality directly, essentially all this is it takes raw HTTP from the user, dissects it and parses it, and sends requests to our backend to make that persistent. So we have 3 different servers here that support front-end functionality, and our load balancer distributes clients among 3 different servers for their session. So to kind of display that, you can see this. If I go to the load balancer ID, which is 9,000, You can see it puts me onto 10,000 this time, and I'm still logged into Bob. If I go back to 9,000 again, it'll put me on 10,001. If I go back to 9,000 again, it puts me on 10,002. So it kind of uses this round robin sort of load balancing while keeping me logged in the whole time because of cookies and persistent state that we support. So to demonstrate the tolerant nature of our front end of our system, if I try to crash the current node I'm on, so 10,002, I try to crash this node, you can see that it doesn't work to access our system anymore through this port because this node is crashed. If I go to now back to the load balancer, it will put me onto a different node. I'm on 10,000 now because 10,000 is a node that works, 10,002 is not a node that works. Go back to the admin console, you can see that 10,002 is now dead. That's the front end. How the back end works, which is something I'm mainly worked on, is essentially it's a way to have persistent data stored in our system. It's a custom key value store based on Google's big table. So essentially how this is structured here is we have three different partitions of data, and all of user's information will go into one of the partitions. How that is determined is based on a hash of their user ID. So the hash of their user ID, for example, starts with an A, it will go into this first partition. Within each partition, it's a primary based replication system. So there's a primary node within each partition and a couple secondary nodes. And the primary node is in charge of all the writes and serializing the writes. So essentially all the writes will go to the primary and will propagate and serialize the writes to the secondary nodes. The secondary nodes can take reads in addition to the primary node. So when a user logs in, essentially they'll be assigned a primary node to send all their writes to, and one of the secondary nodes or the primary node to get their reads from. So as you can see in the raw data here, you can see that Bob's information is within tablet 3, which is within this first partition. So to demonstrate the fault tolerance here, I can try and kill this primary node. So what will happen if I kill that primary node is one of these other secondary nodes will get promoted to the primary node, which will now be in charge of writes. If I kill the secondary node, then it doesn't do as much because all that means is that you can't read from this node. But if you kill the primary node, that means you can't write to that node anymore. So if I kill this primary node and refresh, you can see that this 8081 node is now dead. And this 8082 node was promoted to primary. And to demonstrate that the system still works, I go back to my drive and try to perform a write. So if I go into school and then maybe I want to upload my report for this project into the drive. Refresh, this data is still persistent. This data stayed here and the write worked. That's our PennCloud project. Hope you found it interesting. If you want the code, please email me and I can send it over. Thank you.